In this video we'll explain machine learning and its related real-world applications and how to development. Agenda. Why machine learning? Supervised versus unsupervised learning. Machine learning methods. Real-world applications. Volume of data collected growing day by day. Data production will be 44 times greater in 2020 than in 2009. Every day, 2.5 quintillion bytes of data are created, with 90% of the world's data created in the past 2 years. Very little data will ever be looked at by a human. Data is cheap and abundant, data warehouses, data marts, knowledge is expensive and scarce. Knowledge discovery is needed to make sense and use of data. Machine learning is a technique in which computers learn from data to obtain insight and help in knowledge discovery. Supervised learning, class labels / target variable known overview of machine learning methods. Unsupervised learning, no class labels provided, need to detect clusters of similar items in the data. Parametric models, assumes prob distribution for data, and learn parameters from data, e.g. naive Bayes classifier, linear regression, etc. Non-parametric models, no fixed number of parameters, e.g. KNN, histograms. Generative model, learns model for generating data, given some hidden parameters. Learns the joint probability distribution P, X, Y. E.g. HMM, GMM, naive Bayes, etc. Discriminative model, learns dependence of unobserved variable Y on observed variable X, tries to model the separation between classes. Learns the conditional probability distribution P, Y, X. E.g. logistic regression, SVM, neural networks, etc. Classification, supervised learning. Commonly used methods for classification, naive Bayes decision tree, k-nearest neighbors, neural networks support vector machines. Regression, predicting an output variable given input variables. Algorithms used, ordinary least squares, partial least squares, logistic regression, stepwise regression support vector regression, neural networks regression. Clustering, group data into clusters using similarity measures. Algorithms, k-means clustering, density-based EM algorithm, hierarchical clustering. Spectral clustering. Naive Bayes classifier assumes conditional independence among features. P11 xj xk c equals P11 c P xj c P xk c. K-nearest neighbors, classifies the data point with the class of the k-nearest neighbors. Value of k decided using cross-validation. Leaves indicate classes. Non-terminal nodes, decisions on attribute values, algorithms used for decision tree learning. See 4.5 ID3, CART. Artificial neural networks, modeled after the human brain. Consists of an input layer, many hidden layers, and an output layer. Multi-layer perceptrons, radial basis functions, Cahonan networks. Validation methods, cross-validation techniques, k-fold cross-validation, leave one out cross-validation, ROC curve, for binary classifier, confusion matrix evaluation of machine learning methods. Some real-life applications of machine learning, recommender systems, suggesting similar people on Facebook/LinkedIn, similar movies/books, etc. on Amazon, business applications, customer segmentation, customer retention, targeted marketing, etc. medical applications, disease diagnosis, banking, credit card issue, fraud detection, etc. language translation, text-to-speech or vice versa. Real-life applications. Wisconsin breast cancer dataset, instances, 569 features, 32 class variable, malignant, or benign. Steps to classify using KNN, load data into our data normalization, split into training and test datasets, train model. Evaluate model performance, breast cancer dataset and KNN.